All right, so number 15 is easy. I guess you figured out already. So let's skip it. Let's go to number 16. All right, we are talking about probability. So yeah, there are 522 university students, and 219 said that they were opposed to legalization of marijuana. Who are those 219 students? All right, so anyways, so what the probability? What is the probability that the survey student oppose the legalization of marijuana? So the probability is going to be of that event E, let's call it E. Total is 522, you're going to be on the bottom. The top, you're going to be 219, right? So by the way, the probability of E is going to be how many in E divided by how many elements are into the sample space. All right, sample space is the total, and the E is basically the event. If I would have to graph the Venn diagram, this is going to be my Venn diagram. There's going to be a circle inside. So the event E is a circle. There are 219 that they are saying no to marijuana. All right. And the total number over there is 522, right? So that's going to be 219 over 222. We good? Again, another simple question. All right, find the missing value so that the following represent a probability distribution. So what could be this number over here to make it distribution? What must be satisfied? Very good. You have to add them all up to get 1, right? So if I will call this one X, then 0.24, that's the missing number, 0.5 here, and 0.02. If you add them up, this is going to be 6, this is going to be 7. So what is missing to go to 1? I'm missing 0.24, right? That's X in order to get 1. Are we okay? We good? So the sum of all probabilities, they must be equal to 1, right? All right, so that's A. For the second question, the sum of probability, that's a hint, right? Forget about it. 18. Oh, not so bad. We are almost there. All right, 18. What we have in 18, we have a table. As you can see here, the table, we have major flow, no major flow, minor flow, no minor flow, right? Whatever the exercise is talking about. We have the thing that you need 540 units. Okay, so now find the probability that randomly chosen cheese package has a flow, major or minor. That means it has to be a flow, right? So either major or minor. So what's it going to be? If I highlight the major flow over here, so it's going to be, those are the major flow, right? If I highlight the minor flows, this is going to be a minor flow, right? So it could be a major flow with no minor flow, makes sense? But still flow, right? So for example, this one here, the 35, although it is no minor flow in there, but still a major flow. So there is a flow, right? It's counted as flow. Are we okay with this? So it doesn't have to be both. It can be one yes, one no, right? So now, if you're going to count the number of, all right, again, the probability of an event, please remember the probability for any event is going to be the number of the event, how many in the event divided by the number of sample space, right? How many in total? The total, we have it already here, 540, right? So we're going to divide by 540. Right now, if I'm going to do the first one, which is A here. The A will be the sum of this number plus this one, add them all up, divide by 540, basically, right? So this is going to be, can be a fraction, 25 plus 35 plus 53, divide by 540. Of course, you got to use your calculator. So 60, 53 is going to be 113, divide by 540. So it could be a fraction, or you could be better if you turn it into decimal. So anybody did 113 divided by 540? (0.21). Thank you. So that's the probability. Are we okay, guys, with this? Easy? No big deal? Okay, good. Now let's clear the chart again. All right, let's go to B. Find the probability that randomly chosen cheese package has no flow, no major flow, sorry. So let's go to no major flow. What are the no major flow? No major flow here. These numbers, two of them, right? So you're gonna add them up and divide by. Very good. So no major flow is gonna be 53 plus 427 divide by 540. And this is gonna be 457, no, 480 divided by 540. Anybody did it? 89%. Thank you. 0.89. Okay, whenever they ask about probability, put it in decimal. Whenever they ask for percentage, put it in percentage. So they have to say percentage word, right? Now we are in C. So C is find the probability. Let me reset the graph again. We want to find the probability of randomly chosen package has a major flow given it has a minor flow. Oh, yeah. All right, so the given thing, right? So let me explain the given thing, right? Every time you have a given word, the next statement, it became the sample space. So what is your sample space here? It became the minor flow. You see the minor flow over there? So this minor flow that you see it after the given word, it became your sample space. So if I go to the minor flow right now, and I'm gonna box the numbers in the minor flow, this is my sample space. We good? Now I'm gonna go back to the first statement. The first statement has a major flow. So from these two numbers that you see there, let me zoom in. Which one, the major flow, it would be this major flow, right? Okay. So what does this mean? 25 out of the total, it will be the probability you are looking for. Are we okay? So every time you see the given thing, every time you see the given, the second statement will become the sample space. The first statement is your set. All right, it's really simple. So now, if I want to plug it in here, the major flow is going to be 25. I'm going to write it 25 here. And the total of 25 and 53, that's going to be 78. 25 over 78, that will be your probability. All right, anybody did it? 0.32, thank you. Are we okay with the given probability? Great. Are we done? Oh, yeah. No, we're not done. Let's see. So let me move it a little further up. Okay, that's actually I did D. Yeah, I did D. The D is fine. Let's go to C right now. I skipped C. Find the probability that randomly chosen package has a major flow. All right, let's reset this graph. Has a major flow. It seems like we did it. No. I skipped the B then, right? Oh, I did the no flow, right? Okay, good. You're correct. You can do 1 minus. That's correct. Or you can do it from the chart as usual, right? So if I want to do it from the chart here, that's going to be a major flow. Major flow. This is the major flow. They are 25 and 35 divided by the 540, right? So this is, I know where I'm going to put it. So I'm going to put it here. So for C here, for C, you're going to be a 25 plus 35 divided by 540. That's one way to do it. So this is going to be 60 over 540. Anybody got it? 0.21? No, 11. 0.11. That's good. The other way to do it, so I can figure out that probability of major flow is actually equals to 1 minus probability of no major flow, right? Are we okay? And this one is going to be 1 minus 0.89, and this is going to be 0.11. Whatever you feel like, right? So either one of them is good. Any question, guys, about this? Yeah? All right, you're doing great. Excellent. Now number 19 is another story, and yeah, we have to do all of this. This is the main dish, right? So this is what you are supposed to know. Ready? Okay, I'm going to do it with the not calculator. I'm going to do it by hand. Hopefully I have enough time. Once I'm done by hand, probably I do it with the calculator, right? Okay. You are allowed to use the calculator, so if you learn the calculator, it will be a plus. Now what we have, recently a study found that the life expectancy of people living in Africa is normally distributed with an average of 53 years, with a standard deviation 7.5 years. All right. So from this sentence, I can tell the standard deviation and can tell the mean, right? So let me make a note out of it. So this is my mean, it's going to be 53, and my standard deviation is going to be 7.5. Okay. Now, if a person in Africa, this is A, by the way, right? So what you see here is A. The exam is different and stuff. So this is your first question A. So if a person in Africa is selected at random, what is the probability that the person will die before the age of 65? Why? I don't want to know that. All right, so let's see. So if I have to do A, if I want to write it as probability. So do you see I am not in a normal mode? I am, well, although the normal standard deviation is fine, it's not standard normal mode, right? So it's not Z, it's X. That's what I'm trying to say, right? So this is the probability of X. X is being the age. It has to be greater than 65, right? Are we okay? All right. The way that we did it by hand, do you remember standardize it? Using the standardized formula? The standardized formula, what is it? Z equals to X minus the mean divided by sigma, right? Are we okay? Do you notice that the first question, they did not say the word sample? They did not use the number n, sampling n. So we are okay. We do that standardized regular method. So what I'm gonna do is I'm gonna write it down x, leave a space 65 here, and then I'm gonna standardize it. So x minus the mean divided by sigma. And here I'm gonna put the values. The mean is being 53, and the sigma is gonna be 7.5. I will need some people to help me with this. So every time I do the calculation, because it's harder here to go back and forth, right? And are you right here? Thank you. So this is going to be this way, this way. Thanks. All right. So it's less, right? So now, if I do the calculation here, this is the probability. This, remember, it became a z, right? That's what I want to get, right? And 65 minus 53 divided by 7.5. Anybody got it? 1.6. Thank you. 6 something. 60. So how would this number, the z number, it has to be 2 decimal places, right? Yeah, probably I need to switch to the z table. Okay, let me pay a small tail, right? So if I graph this, if I graph this distribution here, this being my z-axis, this is going to be the 0 here, all right? 1.6 is going to be somewhere in here, right? Z equals to 1.6, correct? If I am less than 1.6, so this is the z I'm talking about. So you are looking for actually this area in here, all right? And you see the big tail. So whenever you go to your table, you don't want to use this one, you want to use the big tail one, right? And you look for 1.6 over here. So 1.6 is 1.6, it's going to be 94.52, right? I cannot write in here. So, but you got it, right? 1.60, right? It's going to be 94.52. We good? And that's the first question, right? 94.52. Okay, thank you. So that's the area, by the way, right? We are looking for. Already? Any question? No? B. So for B, what is the probability that the person will die after the age of 65? Now we are looking for the probability of X greater than the age 65. In this type of question, because we did less than 65, we don't want to sweat here. So we're going to use the complementary. This is going to be 1 minus probability of X less than 65. We are okay? So, and this is going to be 1 minus 0.9452. All right? And whatever is going to be on the calculator. So it's going to be 0.8450, I think. We good? I know if they gave you in percentage. So if it is in percentage, this is 94.52%. If this is in percentage, it's going to be 5.48%. Okay. And by the way, the probability that we just found right now is this probability, right? So this is the tail, this part of the tail. Before, what we just found earlier, we found this part of the tail, and the yellow part and the red part together are going to be 1, right? Okay? Good. That's B done. C. What is the probability that the person will die between the age of 41 and 65? Of course, if they are talking about death, I need to stop them. All right, we are back to business. So the probability of this one, we're gonna do exactly the same thing, guys, right? Standardize, as long as there is no what we see, there is no sampling, we're gonna keep doing the same formula, right? So this is gonna be equals, you do the probability, you leave some space, 41 space x space inequality 65 space, and over here, right? We good? And then what we're going to do, we're going to try to standardize everything. The formula of standardization is going to be minus the mean. Well, let me do it on the x first. So minus the mean here, divided by sigma. That's the formula. So now I'm going to substitute the mean by 53, sigma by 7.5. And I do the same thing on the right side as well. Minus 53 divided by 7.5. Now, what's going to happen? Probability stays. You need to get me this number, the first one, please. This number here became a z. And I need the second number as well, right? Why not somebody here would do the second number? They are working on the first number. Say again. Negative 1. Then this one, 1.6, we got it already earlier, right? So negative 1.6, 1.6, right? Are we okay? So now, whenever you do this, what you're going to do, you're going to look for the probability on the table of 1.6, the biggest one first. And with this one, we got it already, 0.9452, if I remember correctly. And then I'm going to take away the probability of the second one, which is minus 1.6, all right, from the table. Although I know what is it, is actually 0.0548, all right? But let's go to the table and figure out that anyway. So this is going to be negative. You read it as it is, right? So if it is negative, you're going to be on the upper table here, minus 1.6. Minus 1.60, you're going to be right here, the number, if you can see it, guys. Minus 1.6, that the first number is in front of minus 1.6. You're going to be 0.0548. All right? Okay, and then you're going to do the difference, and that should be your probability. And again, it will be great if you can make a difference. Thank you so much. So this is 89.04% if you have it in percentages. Okay, so far so good then. Great. Any question, guys? Okay. We did A, B, C. So let's go to D. Now for D, they are saying if 1,000 people living in Africa are selected at random, how many of them do you expect to die after the age of 65? So we have 1,000 people. And how many do you expect that they live? No, you expect to die after the age of 65, 65 and older. So this is the probability that we did it earlier, right? It was A, I think, or B? Which one? 65 and older. So do you see here, what is the probability of the person will die after the age of 65? That was B, right? This is the question, right? B. After the age of 65. Papers. This one? Like printout? No, I never print out that. Sorry. Okay. Anybody? We did the probability already. All right. So what was the probability of 65 and older? It's 5.48%, right? Or 0.0548, right? And if you have 1,000 people, just multiply that probability times 1,000, and you get the number. You got it? So if they are asking you about the expected value, how many, all right, what you're going to do, so for D here, what you're going to do, you're going to multiply the 1,000 people times the probability of X greater than 65. All right, so this is going to be 1,000 times 0.0548. All right, and if you do that, the decimal point, you're going to go backward. How many digits? You're going to be 54.8. And if you round it, you're going to be 55 people. Everybody got it? We cannot count 54. I mean, I guess. You have a multiple choice. So if you have a multiple choice, you should check your multiple choice. If it is open-ended question, it's fine either way, as long as you know how to do it, right? Okay. I hope this is clear, guys. Do you have it on your blackboard, the test? All right, P90, which is called the 90th percentile. So separate the bottom 90% from the top 10%. What letter was that? E. Thank you. So if I had the normal distribution this way, all right, this is my z-axis. So you're going to separate the bottom 90%. This is going to be 90% of the distribution. Whatever remaining is 10% over here, right? We good? So there are two ways to do it. So if I want to find the z, I will go honestly with this, the first one. So if it is 90%, how can I write 90% in decimal? 0.9. And remember, you need to put 4 decimals for the areas, right? So I am looking what number might be corresponding to 0.9000. And that you're gonna go to distribution here. So obviously it was a big tail because we graphed it, and we are looking for 9,000. So look for the closest number to 9,000. And I cannot figure out. Yeah, there you go. So do you see here? I have two numbers. I have 9,015 and I have 918. Well, I have 8,997. Which one closer to 9,000? The 8,997, right? So is missing 3. The other one is exceeding 15. So I will go with the 8,997. So I need to read it, what the value of that one. And that's going to be 1.2. And then I read the top 1.28. We good? And go back. So this is going to be well, not that one. This is going to be 1.28. Are we okay? Now, that's on the z value, right? Can you check the answer for this one? They give you the z value only, or they give you in the x value? They're still following the same thing? Now, I'm going to do the x value anyway, right? So suppose you get the z value already 1.28, and you want to figure out what the x value. Remember that if you want to go to the x values here, you have to do the opposite of standardized. If I have the x, this is the mean, which is 53, the sigma, it's going to be 7.5. So if I want to go for this direction here, this is what we call standardized. Z equals to X minus the mean divided by sigma. However, if I am going backward, this direction right now, so from the Z, I'm going to the X's. All right? So I need to express the same formula that I have here, but I have to solve for the X instead. So if I cross multiply and solve for the X it would be equal to the mean plus sigma times Z. We are okay with this? Now, if I plug the numbers in, the value over here would be corresponding. This value would be X equals to the mean 53. Sigma is 128 times 7.5, and that should be your value. Are we okay? Please try to plug it in and let me know the answer, please. 60, 63.2, 62.6. All right. 62.6. Whether you round it or you don't round it, leave it for later, right? Are we okay, guys? So 62.6 is the 90th percentile. All right. Okay. We're done with the E. Let's go to the F. Now they are saying sampling. How beautiful. We are doing sampling of 36 people, right? So, and they're gonna ask you, I guess, the same question, right? So they're gonna ask you, the sample mean is, what is the probability that the sample mean is after the age of 65? After the age of 65 means greater than 65, right? Now, I want to bring your attention. There is two indications here. The sample, that's the first one. And the second one, they are saying the sample mean. They are using the word mean with the sample. So they are not asking about the probability of 65 or older. They are not asking about the X. They are asking about the X bars. We are doing the standardization already with the central limit theorem. All right. So here your standardization formula will change. So for F, remember, if you have the sampling, the standardization formula will become Z equals to X bar minus the mean divided by sigma divided by radical n. Please do put a parenthesis in all of them. All right. So this is the new standardization formula. Are we okay? Every time, I mean, after sampling, yes. Whenever you use a sampling, all right, we have two, with all the Z, there you go. This is the standardization formula whenever there is no sampling. Whenever you are not using sampling, you're going to use this standardization formula. All right? If you see the sampling, you're going to use this standardization formula. The work is exactly the same. Then you're going to use this. Yeah. Well, if they don't give you the sampling n is not on the problem, you use it with the old-fashioned way, right? With the first formula. They tell you, right? Okay, so I'm going to do the first one. So the first one is asking for the F, what is the probability of the sample mean is after the age of 65, greater than 65, right? So how can I write it down here? This is going to be the probability of X bar greater than 65. Are we okay with this? After 65, correct? Now, I'm going to standardize it. So I'm going to put probability, X bar, leave a space, greater, 65, leave a space, close the parentheses. So now, on the X side, I'm going to standardize it, minus the mean, divide by sigma, divide by radical n. All right? From this side, I'm going to take the mean, which is 53, divide by 7.5, divide by radical 36. Put the parentheses on them. Are you okay, guys, with this? This is going to be the probability. X bar minus the mean divided by this is going to be Z. This is greater than 65 minus 53 divided by whatever. That's I need. Put parentheses, please, whenever you use the calculator here. Anybody got it? No, it's too much. Oh, radical 36. This is a radical, sorry. Say again? 9.6. Wow, still high. But yeah, I think it's correct. All right, 9.6. Yeah, this is like not really a good calculated question. Because 9.6, the probability of greater than 9.6, I can tell you is 0, right? You got it? Why? Because I'm going to put normal distribution here. This is a Z. So this is going to be the 0. The greater than 9.6. Let's say 9.6 here, right? And you're looking for this tail from the right side. 9.6 is really far away. Actually, is really bad place over there. So it would be like, I'm going to cut this, continue here, and 9.6 is going to be somewhere here, right? And you are looking for this small tail over there. All right. So the farther I can go, by the way, this is obviously a small tail, right? Yes? And I'm looking for small tail 9.6. The farther I can go with the table for small tail, you see those are the values. The farther I can go is minus 3.49. And you see the probability is already 0.002. So if I go even further, nothing left. All right? Okay? So what you're going to do here is the probability 0.000. It could be 1, it could be 0. I mean, the closest probability to 0 is the one that you're going to pick. All right? So that's F. Now, G, use the empirical rule to find the percentage of the person in Africa will die between the age of 38 and 68. All right, the empirical rule, what is saying the empirical rule? All right, the empirical rule is saying that if I have the mean here and I go one standard deviation on the right, on the left, the mean plus sigma and the mean minus sigma. So the mean is 53, right? The mean plus sigma is going to be 53 plus 7 point. Okay, let me check again. Are they doing the sampling or without sampling? Because this is going to be... Uh, 15, yeah, no sampling. So if I do this, this is going to be 60.5, right? And here you're going to be 53 minus 7.5. I don't think I have a brain for this. Anyways, So this is going to be the 68%. Now, if I add another sigma plus 2 sigmas, and here the mean minus 2 sigmas, this is going to be 53, 2 times 7.5, that's going to be 68. That's one of the numbers. And this one is going to be 53 minus 2 times 7.5, and this is going to be 38. And that's the second number, right? Somebody get me this number, right? So this one is not, and this one is not, obviously. Okay? And the second interval, because you know your standard deviations, you know your empirical rule. What the empirical rule here is not about 95%, right? Okay? So you don't really need to calculate with the table here, using only your empirical rule, and the answer would be about 95%. Are we okay, guys, with this? Okay, guys, so what you need to know this probability over here, right? So you need to know that one, right? So what exactly you need to know? How do you do that probability? So I know the mean. So the access to the distribution first. You gotta go to second and vice. Second vice, you have access to distributions. All right? This is TI-84. And then you're gonna go to number 2. You never use the PDF in this class. We use only CDF, cumulative distribution, right? So you're gonna go to 2, enter. So it's giving you already the lower. So that's how the calculator write down the lower. Minus 1 E99. That's minus infinity. All right? And that is actually minus infinity. Do you see minus infinity? That's the lower end. Minus infinity here. This is the lower end. The upper hand, well, let me write it again. So this is the x, this is 65. So the lower is going to be minus infinity. Are we okay with this? The upper is going to be 65. So I'm going to go to the next one and put 65. And then I'm going to go to the next one, the mean right now. They're asking about the mean. Well, the mean is what? 53, right? Are you with me? The mean is 53. So you're going to type it in right away, 53. And then they're going to ask you about the sigma. What's the sigma? 7.5. So that are the information you know. So lower, upper, and sigma and the mean. And that's it. You enter it. You enter here. This is the syntax. If you have a TI-83, you should write it down like this. Normal CDF. That's the TI-83. All right. You don't have the menu for TI-83, right? And I think normal CDF, you can find it under catalog, or I don't know. But anyways, and then that's it. You say enter, and that's the number you're looking for. No table, no headache, no transformation, no calculation. 94.52. That's the exact number. All right, we good? So if I want to do the other one, x is greater than. You let me know about the time, guys, right? I don't really know. So if I want to do the other one, x is greater than 65. So I cannot draw here, so let me see. So this is greater than 65. 65 here, greater than 65. If I shade this part here, what's it going to be? The lower end. The lower is 65, the upper hand plus infinity, and sigma and the other one stay the same, right? So I'm going to go again with second, vars, CDF, enter, I'm gonna change the lower one, which is 65. I'm gonna go to the upper one, which is 1. E, I think the E I'm gonna use is this one. Here, the comma, above the comma. So the second and comma, that's E, and 99, that's infinity. If you don't know how to write E, just put 10,000, 20,000, the big number, right? That's infinity there. The 53 is still the same, 7.5 is still the same, enter, 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 and that's the other number. If you have upper and lower two numbers, you can find that, right? Yeah, my time is up. That's I wanna bring this to your attention. One more thing. If I'm gonna go to CDF and suppose I'm doing sampling right now, what's it gonna change? The only thing gonna change is this, the mean is gonna stay the same, the sigma is gonna change. So I'm gonna write down 7.5 and then I divide it by radical sigma, radical 36, right? So the square root, I think, is right here, square root second, and x squared, the square root, and 36 in here, close the parentheses, and you do the same thing. So upper and lower, you change the sigma, which is 7.5 divided by radical n, and enter, and you get that number, right? Which is 0, by the way, right? That one is 10 to the minus 22, right? That's the one that we were looking for. That's 0. And that's all. So I'll try to post this one online if I can stop recording.